You're taking our x squared plus 4x plus 4 equals 0, the equation we solved earlier by factoring. That's in the form ax squared plus bx plus c equals 0, right? Now remember, when we factored this, we found out that x equals 2 was the only solution, right? Okay? We're going to use a quadratic formula to see if the quadratic formula agrees with what we know to be true. Okay? If we believe the factoring and understand the distributive law, then there's no question that the only possible solution is x equals negative 2. Well, the quadratic formula gives us a solution to this equation. If the equation is ax squared plus bx plus c equals 0, then this gives us the solutions. Okay? So this equals what? Negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 4. All I'm doing is plugging in values of a, b, and c, right? So every a I see, this one and this one, is a 1. Every b, this one and this one, that's a 4, that's a 4, right? Now there's a negative there, but the negative is from the formula. Okay, and c is 4, and the only place it appears is here, and there it is, right? So I'm not 100% confident, but I'm pretty sure I got the right numbers in the right place. But I'm going to check my solution to make sure when I finally get a solution. Okay, so this gives me negative 4 plus or minus. Okay, well, 4 squared, what's that? Yeah, 28, no, 16. Okay, then that's minus, what's 4 times 1 times 4? Well, 4 times 1 is 4, you multiply that by 4, you get 16 over 2. Well, 16 minus 16, you might suspect is 0. You know that. Okay? And we get negative 2. Okay? Now I'm going to say this for future reference. We get that solution twice. One for the plus 0 and one for the minus 0, right? And when we factored this thing, we got x minus 2 times x minus 2. So we got x equals 2 from this one, and we got a negative 2. X equals negative 2 from this one, and x equals negative 2 from this one, right? So negative 2 appeared twice. Okay, so solution it has multiplicity 2. Now if I was you, I'd make note of that term multiplicity and what I said and what it means. Put it in kind of a glossary that you keep with you and refer to if you run into that word and don't remember what it means. Because you might not. But if you've got it written down and have just, a page in your notebook that's your glossary, important terms, now you know what multiplicity means. At least you got an inkling of what it means, and we'll see it again, and it's really important. Okay? Later on in the course, along about early March, it's going to become real important, maybe before that. Okay. So you have that solution with multiplicity 2. Again, once for the plus, once for the minus, happens twice. Check. Two squared plus 4 times 2 plus 4. Negative 2 squared plus 4 times negative 2 plus 4 should equal 0. Put a question mark over that equal sign because we know that if this is a solution, then when we plug it back in here, two sides have to be equal. Well, negative 2 squared is 4, and this is plus negative 8 plus 4 equals 0. So 8 plus negative 8 equals 0. Well, negative 8 is the additive inverse of 8. We know when we add negative 8 to 8, we get 0, right? So that's why I choose to write it out this time. Okay? Make sense? That's pretty easy, isn't it? The numbers might get ugly, but you got a calculator. If the numbers are ugly, go ahead and use a calculator. If the numbers are pretty like this, you should be able to do it without the calculator, right? Okay. Now, everybody knows there's a table for the x squared function, right? Okay. And the graph of the x squared function. Now, if I'm just graphing the x squared function, I only need to go up to 4 here, right? I'm just doing the basic function with the basic values. And I'm going to go up to 16 because of what I'm going to do with this. You're going to be astounded. You're going to love this. At least, yeah. Maybe you will. Okay. Maybe not right away. You'll get to love it. Let's see. Negative 1 ought to go there.
Question.
Okay. So let's see, if 16 is there, this has to be 8, and now 4 is here. So 3, 2, and 1 are pretty close to the axis. Still don't have a very good picture, but on this scale, the graph of y equals x squared going to look like this. Yeah.
You put 2 squared is 2.
What y'all make me think that for? Stop misleading me. Okay. Now, yeah, it's 4. Okay. Now you understand how the graph was made. I don't have to explain that to you. It's pretty flat, flatter than what you'd usually do. Okay. I'm going to do some things with this graph. Okay, first thing I'm going to do I might want to use function notation to make this clear. But no. I'll let you sort that out with the homework problems. I think you'll be able to do it. I want a new value of x, okay? And I want it to be 3 less than the old value. Sorry, 3 more than the old value, okay? So I want to add 3 to every one of these values. So if I add 3 to negative 2, I got new x is 3 plus the old x, okay? So what's 3 added to negative 2? You can hold up fingers, just be careful which finger and how you orient it. It's fun. Good. Yes, yeah, watch that now. Okay, so we got 1. Okay, what if we add 3 to -1? We get a telephone. Okay, that's how you do a telephone, isn't it? I don't do those things. I think it's the first time I've ever made that gesture. Hope I never will again. Okay. And then for adding to -1/2, I should get 2.5. Adding to 0, I should get 3, 3.5, 4, 5, right? Okay? Okay, well, over here, I'm just going to use the same y. There's a process I'm asking you to go through on your homework that's very similar to this, but I use a little bit of function notation. We'll talk about how that works, okay? I want the same value of y. This x I'm going to call x old. This is no longer x. This is x. Okay? I'm going to take the same y values and now I'm going to plot the y values versus these x values. Okay? So I've got like a new function. Okay, so where's my first point going to be? I'm going to have x equals 1, y equals 4, right? Okay. Well, that means x is going to be 1 and y is going to be 4. Now, I'm going to put a purple curve around these values of y and these values of x, and I'm going to graph this in purple, okay? So my first point is 1, 4. That's here, right? Would you agree that would be the point 1, 4? Okay, so here's the point. One, 4. Okay, then I have 2, 1. Well, that's 4, and 1's going to be down here. So that should be the point 2, 1. Okay? I'm not going to worry about 2.5, 1/4, because 1/4 is so tiny the way I scaled this graph. Okay? But you see, I'm going to have to go out to 3, 4, and even 5 to plot this purple graph. Okay? So if I go to 3, my value is 0, isn't it? And if I go to 4, my value is back up to 1. And if I go to 5, my value is 4. Does that make sense? You might not understand why we're doing this, but that makes sense. Okay? Then I go ahead and do my curve. Chalk stuck a little bit, made it go below the axis, but you understand where it's supposed to be, right? Okay. Now just visually, does this curve have the same shape as this one? Yeah, if I've graphed it accurately, then if I take this curve and move it over on top of this one, it's going to completely cover it, right? Okay? Now I graphed it freehand, so it's not exactly right, but you see it's plausibly the exact same shape, okay? What's the difference between this curve and this curve?
Orientation on the x-axis.
I'm sorry?
Orientation on the x-axis.
Orientation, I wouldn't say orientation, I'd use the word position. Orientation's like, is it concave up or concave down or on its side or something, okay? That's how I'd use the word orientation. Nothing wrong with you having used it, but I'm going to say position. How does the position compare?
It was shifted to the right 3.
I'm sorry.
It was shifted to the right 3.
It's shifted 3 units to the right, isn't it? Okay? So, this graph is just this graph. With every point shifted, three units to the right. That makes sense? Okay. Use the word if. Your first function is y equals f of x equals x squared. Okay? Second function is y equals f of x minus 3. Okay? You might not believe me, but I'm going to prove it to you. Now, if f of x equals x squared, what's f of x minus 3?
X minus 3 squared.
Again?
X minus 3 squared.
Didn't hear everything.
X minus 3 squared.
X minus 3 quantity squared, right? Because it always helps to know what f of aardvark is. What's f of aardvark? If f of x equals x squared, what's f of aardvark?
Aardvark squared.
Yeah. There's an aardvark. Aardvark squared. Now, if you can figure out what f of aardvark is, you can certainly figure out what f of x minus 3 is. What is it? Well, here, you've replaced x by aardvark, you got to replace this x by aardvark, and you get this, right? Just rewrite this definition using aardvark instead of x, it reads this way. Now, here, We just do the same thing. Instead of x, we've got x minus 3. So we just rewrite this where every x is an x minus 3. And that's x minus 3 squared. Okay? So if x equals 2, what's f of x minus 3? Well, it's x minus 3 squared, right? And if x is 2, what's that? Well, what's 2 minus 3? It's negative 1. What do you get when you square that? Square negative 1, you get, yeah, don't use that figure. Okay, now, okay? Now, on this graph, when x equals 2, what's the value of y? Well, right there it is, it's 1. And of course, your table tells you when x is 2, the y value for the purple function is 1, right? So it agrees. What about if x equals 5? What do you get if you plug 5 in for x? Well, 5 minus 3 is 2. 2 squared is 4. Okay? What's the graph? When x is 5, the y value is clearly 4, right? Okay? So what we're saying is just looking for a good place to write this. I think I might have room here. Graph of x minus 3
You sound like my mom over here. I think that just made
is the graph of f of x shifted 3 units and, important word, horizontally, 3 units in the horizontal direction, right? Does that make sense? And we've demonstrated that for this function. And for homework, I'm going to ask you to do some similar things. In general, this should at least make it believable.
Have a great weekend.
Okay? Graph of f of x minus h is the same as the graph of f of x, but with every point shifted h units horizontally. Meaning if this is minus h, the graph shifts in the positive direction. Okay? And if you think about what I just did over here and think fairly hard about it, you'll understand why the graph shifts in the positive direction if you replace x by x minus h. And that's for any graph, not just for a graph of f of x equals x squared. Okay? And if you understand that example, and the examples I'll ask you to work on, it becomes clear why that is. I emphasize this because there are three basic transformations that we use with most functions to build new functions that we can do something with. Okay? And the hardest one to understand is this, and the one that people forget the rule on is this. I want you to understand as best you can why this works so you don't forget what happens and get messed up. Okay? And we'll do a little more with it, but I want you to work the homework first. Okay, so ultimately, we're going to, as I said last time, I'll have to do this in a video and ask you to time the video. It will take you maybe 5 minutes, okay? And we're going to want to know the time when the water crosses each one of these marks, okay? And what you're going to get is going to be data that look like this. Okay? If you plot your depth versus your time, you get points like this. If you've got 4 points 4 times, plot them on a graph. You can easily do that. You did it with a pendulum. You're going to have 4 points here, okay? Make sense? Then there's a curve that'll fit these points. I talked about this last time, but it's worth repeating. Okay? This curve is going to be quadratic, so there's going to be some point at which it reaches 0, although you won't actually observe that. Okay? You'll observe it, but we won't worry about that. Okay, so there's some point here, some time at which the depth stops changing, and it might not be 0. Because we're going to measure the depth. We could measure the depth from the bottom of the container, right? That's how deep the water is. Well, water's going to stop flowing out when it gets to this level. That's not depth equals 0, is it? Okay? Or maybe we measure depth relative to this tube. We find that the water actually stops flowing when it's a little above the tube. Okay? So, however we measure it, the depth is going to become 0. Depth is never going to become 0. But the depth is going to stop changing when the water stops flowing out, and that's going to be at some depth greater than 0. Okay? Well, how do we get this graph? So this is, I'll use t for my variable. Actually, I don't want to do that just yet. Confuse things, okay? So we got this curve. And over here, we've got our graph of y equals x squared. Okay? What we can do with what we just learned is if we estimate what this time is, okay, so let's say this is where t equals h. Well, we can take this graph, this y equals t squared graph, And it's all smudged, but that says y equals f of t equals t squared. That's this graph. We're going to take that graph and we're going to shift it over to here. And this is y equals f of t minus h, whatever h happens to be. If we find that this curve should be leveling off at h equals 120 seconds, then this would be t minus 120, if t is measured in seconds, okay? And we've just seen how to do that. Then, does this curve have the same shape as this curve? Well, as we saw last time, we don't want to use the whole curve because having a depth that goes down and then back up doesn't correspond to what happens when water flows out of that thing. It doesn't flow back in. Okay? So we restrict the domain. We don't use this half, but we'll still put it on our picture until we cross it out. Okay? But what do we have to do to this to give it a shape that matches this? We have to flatten it out, don't we? Okay? So we flatten this thing out. To match the shape of our data curve. Turns out to be real easy to do that. Okay? Then what do? It still doesn't match this curve. What do we have to do to make it match the curve? I mean, what's different between this curve and this curve? They have the same shape, if it's wrong, right?
Let's shift it vertically.
You got to raise it up a little bit, right? Okay? So let's see. I don't know what happened to my yellow chalk, but I've got enough to draw a curve.